Welcome to Brain Playground Episode 4, Intro to Textures. In this video, I'm going to show you how textures are created in OpenGL. So this is something that took kind of hard for me to wrap my mind around for a little bit, so I spent some time really trying to understand how the textures are created. So what I'm going to do is I'm going to start by showing you these are the files, or these are the methods included in the Hazel game engine. This is my own little Brain Playground version of the Hazel game engine. And what you can see, these are all the methods inside of OpenGL texture.h and OpenGL texture.cpp. So just to kind of go over like what this format is. In this header file, there's a couple of includes, and then there's a namespace, and in that namespace a class is defined, this OpenGL texture 2D. And then I kind of blow that out over here, and we have class OpenGL texture 2D, and these are all of the methods and constructors and destructors included in that class. These are all the private data members of the class. And then over here, the CPP file, this just kind of outlines what's in that file. You have some more includes, and then of course you have all of the definitions for all of the elements here that are not defined in the header file. So for example, these two constructor overloads, this destructor, and these two methods are all being defined in the CPP file, but some of these other methods are being defined in the header itself. So that's why the different colors. So everything I'm going to be talking about is actually occurring in the OpenGL texture 2D constructor. So we're going to go look at the texture architecture and the actual OpenGL function calls that we make to load our data into a proper texture. So the texture object looks kind of like this. So it has some name, which we've named it mRendererID, and it has a bunch of information for the image itself, and then information that's going to go along with how to use the texture and kind of some more data about the texture. So how do we get all of this into this object, and how do we create the object in the first place? So it all starts with this GL create textures. So I'm gonna go through each of these functions, and at the end we'll come back to this image and review. Alright, so the type of textures that can be created with GL create textures are shown here. So this GL create textures basically creates the shell for the texture, the object. It's like, here's the container, and then we're going to load some stuff in there. Now in this container, so we have GL create textures. We're going to tell it we want to make a GL texture 2D. That's a common type to make. So that's that first argument here, and that first argument could be any one of these, but texture 2D is a common usage. We're only going to make one texture, so that's the number of textures we want to make, and then this is the memory address or the name of the textures that we're going to use. So this is going to be an array because it can hold more than one texture. Okay, and the last point about creating textures, the GL create textures function was added in OpenGL 4.5. In older versions you would use GL gen texture, which would just give you this n and this textures argument, and then you would have to use GL bind texture to get this texture target. So these are texture targets. And then this is our texture name. So in this GL bind texture, you would add a target, and then your target, and then your texture name, which you would have defined up in GLGen texture. So the next thing we need to do, now that we've made our texture object, is we need to start storing data in it. So the first thing we're going to do is we're going to tell us about the data that we want to enter in for the image. So we're going to use GL texture storage 2D. So this is going to be a 2D texture. And that means that it has to be one of these types. So when we create the texture, these are the only types that are allowed in order for us to then use a 2D storage. So we use GL texture 2D, so we're all set there. A little circle. All right. So next in here, so there's our mRenderer ID. That's the name of our texture. And then this number refers to the levels. Levels refers to MIP maps used for textures. And MIP maps are a scaled down version of the texture image. So in other words, a smaller texture image. And it's used to, it's used when you want to render, when you want to make your object smaller. You kind of decrease the size of your object. You might want to use a less complex texture, so a scaled down version. And that's basically what a MIP map is. Oops, went too fast, sorry. And then the next thing, internal format, that refers to the type of data to be stored for an image. And common formats are GL-RGB8 and GL-RGBA8. And then width and height are self-explanatory, so I won't go over those. Okay, so you're basically now telling your texture object, hey, I'm going to store some stuff in you, and I just want you to know the stuff's going to look like this. That's kind of what this function is doing. Now I just want to quickly go over RGB8 and RGBA8. So what do those formats mean? Well, GL-RGB8 is basically the image format. So most images that are color images are some form of like red, green, blue channel. That's how screens display images. So most of the time that's how image files are kind of designed. So the 8 tells us the size of the data. So this 8 means an 8-bit image. And here I have a column showing an array of bits, or 1 byte. 8 bits is 1 byte. That's how we're going to store the color information in these bits. And we're going to store information for red, green, and blue. And then over here, if we're using the extra RGBA data type, that A is for the alpha channel, or transparency. So let's just kind of go through what this looks like. If you have all zeros in the red slot, you're not going to have any color there. So it'll just be black. And if you have ones in all of your bits, then you'll have 100% red. Same thing is true for green and for blue. And then if you have some combination of zeros and ones, you're going to get a color somewhere in between that black and that red. And that's going to be the same for green and the same for blue. So these are the binary numbers. And these here, just for reference, I put the hexadecimal numbers. A lot of programs use hexadecimal to set color types. Or to set colors, I should say. Not color types. Okay, so what I did over here is I did the same principle with the alpha channel. So if you have all zeros, you basically have full transparency. There's no opaqueness of the image. If you have all ones, you have a fully opaque image, so nothing gets through. I put this little blue cloud behind there, so you can just see it coming through here fully, not so much here, and then you can see a little bit of detail here as it bleeds through where we have this this in-between value of transparency. And then just for fun down here, I made some cubes. This is what happens if all of your RGB channels are 0. This is what happens if all of your RGB channels are 1. You end up getting, when you blend all of these colors, you end up getting a white color. Then finally, this third row that I have made here, this is the color output of that when you blend all the colors together. And then this one is the gray color, but I've also used the mid-range alpha there. So you can see that there is some now some transparency with that object. Okay, so that's basically what the color, that's basically what these GL-RGBA and GL-RGBA8 are doing, is it's just telling you what your data is going to look like, and just to give you an idea of what those mean, I've illustrated that down here. Okay, so the next thing we're going to do is we're going to talk about GL texture parameter. This is a function that basically tells the computer how to use our texture when it is trying to sample from it. So it takes in 3 parameters. It takes in our texture, a parameter name, and then the parameter itself. Again, the GL texture parameter is a newer function in OpenGL 4.5. The old version was GL text parameter. And these things work a little bit different. The GL text parameter takes in a target, and then you'll have to assign your texture to it later. The GL texture parameter takes in the texture itself instead of taking in the parameter. And as we've already specified earlier in the process, we've already established that our target is GL texture 2D. Now there's lots of different, not lots, but there's several different versions of this texture parameter function. Notice there's an I here. I've just kind of defined what the different letters mean when they're after here. So if there's an I, it means that the argument 3 parameter is a GL int. If there's an F, it means that that value is a GL float. U is a GL unsigned int. And if there's a V, it means that the argument 3 is a pointer to the parameter. So if you see those letters, that's basically what they mean. Okay, so we put in our texture. Our texture is the mRenderer ID still. And then the name of the texture, so there's multiple different texture settings that are allowed. I'm only showing 4 of them, but there are others. So this is a min filter. What happens when I shrink the image? What happens when I grow the image? What happens at the edge of the image in the X direction? What happens to the edge at the edge of the image in the T direction or Y direction? And for the textures, they use the coordinates S and T. Over here under parameter, these are for each P name. These are the set of parameters allowed. So we can have GL linear, which is going to take into it's basically going to kind of make a gradation of color, which is going to blend your colors really nicely if you minimize the image. And it's going to kind of recalculate what color should go in each pixel. GL nearest is going to choose the nearest pixel color and just make the new pixel that color. That can make a picture look kind of blocky, so linear is a good choice for the minimizing. These are some other more complicated choices when you're using bitmaps. And then here are some settings for the mag filter. And then for the texture wrapping, clamp to edge is going to make your texture fill the window. A repeat is going to make your texture, when it gets to the edge, it's just going to create another copy of the texture next to it, and just keep doing that for the extent of the image. Okay, so right now over here you can see we have mRenderer ID, we have GL texture min filter, and for that we've chosen GL linear. Okay, finally we have GL texture sub image 2D. This is where we're going to load the actual image data into the texture. So here are the arguments to this function down here. So the first thing is the name of our texture, and then if you want to start the texture anywhere but the origin corner of the window, then you want to, or the origin corner of the object, you want to take away your x offset, and you want to set your x offset and your y offset. Width and height, those are self-explanatory. Format, the format is going to be the color format, and these here are our color formats, and you can see that we have for our format, well, it was hidden in a variable called data format, but usually it's going to be GLRGB or GLRGBA. This should look pretty familiar. We just went over what these things mean. Notice that there's no size indicator here, so this is a little bit different flag than the types that we used before. And then I shouldn't have said type, because of course type means something specific now. This is the type of data in the image, so this is our color space, and this is the type of each data point, and it's a GL unsigned byte. So it's 1 byte, 8 bits, unsigned, all the values are positive, and those values can be anywhere from 0 to 255 in an 8-bit or 1 byte data. And then finally we have a pointer to the data. So the matrix of every single pixel value will be stored somewhere, and here this is just a pointer to that stored data. So let's go back to our original image here and just kind of review. So GL create textures creates this texture object, and then we start loading in features. And of course with this GL create textures we've given it a name here. There's the name. So then we're going to say for the image storage, this is how much space you should probably set aside for the storage. Then we're going to tell you what to do if we shrink the screen, shrink the object, magnify the object, or what do we do at the edges of our texture. Those are all going to get loaded into sampling parameters. And then the final thing, we're going to load our texture data along with a pointer to the data itself, and that will go in, and that is kind of described as our texture parameters. And that kind of illustrates what an OpenGL texture looks like, and how it's created, and how we load the data into that texture.